Good morning, friends. Today we'll cover chapter 16 of our tutorial series on Apache Spark, which is closures and shared variables. And then we'll go into more details about accumulators and broadcast variables. So first, before we try to understand more about broadcast variables and the shared variables in Spark, first of all, we need to understand what are closures, because shared variables are very much in line with how the closures are defined. And then we will try to understand what is the closure concept in Java lambdas, and then we will proceed with Spark. Suppose we have got a normal Java class as here, for an example, stock position accumulator, and it has got two member variables, one long, and one is another reference to a class called a stock position. When we have got constructor, and now we have got these individual methods. As you can see that these methods it can refer to the member variables here. For example, is0 method is a very simple method which actually refers to the count member variable of this class. But for copy, it can declare a lot of local variables, the variables which are local to this method, which are say security ID, position accumulator. So all these two like variables, these are the local variables for this method. And whenever a thread is running, as we know that each of the thread has got its own local stack. And in that stack, when this method is called in a particular thread, then all these variables would be actually allocated into the thread stack, not on the heap. Only those new operators, all those new the objects which are created inside this, that only would be stored in a heap. But all the local variables would be in the local thread stack, which is running this method. Now, a closure is an instance of a function. Instance of a function is very much similar to that how we have got lambdas in Java. But just treating closure as a generic concept, a closure is an instance of a function that can reference non-local variables of that function with no restriction. So non-local variables are what? As we have discussed that in the function, we have got all this, let's say, security ID and position accumulator. So these are all like local variables. Non-local variables are outside this function. So if we are defining this closure as an instance of a function, how it can reference non-local variables of that function with no restriction. So this is the concept of closure. For example, a closure could be passed as argument to another function, just like lambdas in Java. And it could also access and modify variables defined outside its scope. So this is a generic definition of closure. Although it's like a little bit confusing, but once we understand the same closure concept in Java, it would be very clear. So let's try to understand what is closure concept in Java. In Java, as you know that lambda expressions, which are introduced in Java 1.8, these are basically instances of functional interfaces. Functional interfaces are one which has got only one single abstract method. It can have several default and static methods, but only one single abstract method. For example, we have got runnable interface, and in which we have only got one abstract method as void run. Similarly, we have got, say, supplier or consumer or whatever. So there are a lot of functional interfaces available in our Java API. But the basic idea about functional interface is that it has only got one single abstract method. And lambda expressions are basically instances of functional interfaces. So this is exactly same as what we were talking about closures. That closures is an instance of a function. So this is a generic concept outside of, generic to like Java or Spark or Scala, whatever. So this is, as we have known that Java lambdas and anonymous classes do something similar to closures, as we have discussed just now. They can be passed as arguments to methods and can access variable outside their scope. This point, which is something important to learn about if you want to learn about closures. But all these like lambdas, they have got one restriction, that they can access and modify the non-local variables to that function, but that variable should be final or effectively final. Effectively final means that even if we have like not used the keyword as final, but if the variable has been only initialized once and not initialized and not changed later on, that is also considered as effectively final. So the lambdas, they can access, but they can't modify the content of a local variable if they are not marked as final or effectively final. So this is what the restriction is in Java lambdas. But in closure, as we have learned as a generic concept, that it could access and modify variables defined outside its scopes. But in Java, the only difference is that the variables should be final or effectively final. Now, this restriction, that why it was implemented like this, is that whenever these local variables, as we have learned that in Java, all the local variables inside a method that is confined to that thread which is running on it, allowing capture of this mutable local variables. Those local variables which can be mutable, which are not final or effectively final, if they can be captured outside, inside that closure or the lambdas, which it can actually open a lot of thread unsafe possibilities. Because it's also possible that the lambdas that we are creating and which are accessing those non-final variables outside the scope, and it is run in a separate thread, then it can actually open a lot of issues which are undesirable. It is different than the heap, because the heap is always accessible to all the threads from their own stack, so that is fine with heap. But for the local variables, if we are not marking it as final, then it can actually cause a lot of thread issues. Now, looking at this unit test case example, here I have defined this variable string name as John, and now this is my lambda, which is a concept of closure, and this is a enable that when this thread is run, it should be printing this name. Now, this name variable is outside the scope of this lambda, and right now we can also see that this name has been changed here. So it's not actually effectively final as well. So there's no final keyword here. And also it is not effectively final because this name is actually changing. So if I try to uncomment this, we'll see that this is not getting compiled. If I just hover over it, it will state that variables used in lambda expression should be final or effectively final. So either we have to change this assignment here, or we can change this as final variable. If I change it as final and remove this, then we can see that now this code is able to compile. Okay, so this is what we meant. And suppose if I even haven't put anything here, final, and I just comment it here, so this is right now effectively final. Okay, so because this name is not changed later on after this, so that's why this is able to compile. So this is what we meant, that whenever we are using a lambda expressions in Java, and the variables it is accessing outside the scope of this, so outside the scope of this lambda, that case, those variables should be final or effectively final, otherwise the code will not compile. So as we have understood the generic concept of closure and the closure concept in Java in lambdas, that it should be only all the variables which are accessed should be final or effectively final. In the next video, we will extend our concepts to Spark, that how this closure concept is used in Spark, because that would be effective in understanding accumulators and broadcast variables in Spark. So see you all in the next video.